so my name's Jenna Gregory. I'm a senior clinical lecturer at the University of Aberdeen. So clinically, I work as a histopathologist. We're interested in looking at human tissue, not just clinically, but in the research as well. And then my research interests are understanding non-neurological manifestations of neurodegenerative diseases. So in particular, motor neuron disease. Just recently had a paper published where we've looked at non-neurological manifestations of motor neuron disease. So that is patients who have motor neuron disease, people living with motor neuron disease, frequently report gastrointestinal particularly symptoms. So that is things like weight loss and feelings of sickness and diarrhea and change in bowel habits. And these symptoms are often overlooked, but we were interested in looking to see whether tissue that had been collected during the lives of these people had any signs of motor neuron disease. And actually what we were able to see was that even years before these people started to develop neurological complications, they actually had symptoms affecting their gut tissues. And so that is these proteins that abnormally clump that we think cause motor neuron disease, that these clump in the brain causing neurological symptoms. We were actually able to find these clumpy proteins in the gut tissues years before these people developed neurological symptoms, so motor weaknesses, motor symptoms. So this is quite a major finding really, in the sense that not only that there is a kind of biological explanation for these symptoms that people are experiencing, but also are often overlooked, but also that this could give us an opportunity for an early diagnosis for motor neuron disease and other related dementias. I think it's really interesting to think about the gut-brain axis as an entity. You know, our gut and our brain, they're physically linked by a nerve called the vagus nerve. And they're also linked chemically. The gut produces a lot of the neurochemicals that our brain produces, for example, dopamine. There's a lot of neurons and nerves within the gut. Obviously, there are within all tissues in the body, but there's a lot of neurons in the gut. And so we classically think of motor neuron disease as affecting just the brain and just the motor cortex. But actually, like you mentioned, there are lots of neurons within the gut that are obviously affected by this disease that we've seen in our paper. Whether this is due to microbiome or the bacteria in the gut, or similar pathological things happening in the gut like are happening in the brain, we don't know yet, and it's certainly something that we're interested in and others are interested in investigating, particularly as diseases like Parkinson's disease. This is another example of such a disease where you have neurological symptoms, but also you can have gut manifestations. That has been shown to be physically these proteins that are connected, the brain and the gut are connected, and these proteins have been shown to physically transmit up the vagus nerve. But there is also obviously an impact of microbiome and inflammation in the gut that could be contributing to this as well. So I think that with respect to diagnostics and whether you could use something like this as an early diagnostic test for motor neuron disease, there are lots of ways that we could think about this. And in particular, in the UK, for example, we have a really successful bowel screening programme. So particularly people over 50 are routinely screened for blood in the stool, for example, which could be a sign of a bowel cancer. Often these people will go on to have biopsies taken, and we could therefore screen people at that stage, even without having to do an additional test for people to screen for signs of neurological diseases. Alternatively, if people felt that they were at risk, it could be developed as a diagnostic test where you could take a bowel biopsy, particularly from the rectum, which is a more accessible part of the gastrointestinal tract. But actually our research focus over the next short while will be to see if we can detect any differences in the surface layers of the gut that are sloughed off into the stool, to see whether we can detect this in a stool sample. And that will be the next focus of our research. It's a really good question to bring up around whether early diagnosis is useful in an instance where we don't have active therapeutics in the disease. it's interesting for several reasons. We do have clinical trials ongoing currently for people with motor neuron disease. So I think that those treatments will become available certainly in the in the next 5 to 10 years. In the meantime, I think that it's important to bear in mind that if you look at a lot of the animal studies in the preclinical literature, if you can intervene early with the animal models, you can actually eliminate the disease. And so really a lot of our therapeutics and clinical trials are aimed at post-diagnostic treatments. But actually what we're showing is that we could then be targeting clinical trials to people before they've even got motor neuron disease, before they've got neurological symptoms. And, you know, based on the preclinical literature, that could have much more success than waiting until people have symptoms. So I think that, you know, this is an evolving area, you know, my absolute dream really would be that we could start intervening in these situations years before people get neurological deficits so that we can prevent the disease completely. I mean, that would be the dream, really. We're very collaborative researchers, and we collaborate widely, not just within the UK, but also with people in Italy and in the United States. You know, this work really benefited hugely from collaborations within Scotland. We work very closely with our collaborators at the University of Edinburgh, and also with NHS Lothian in Edinburgh and NHS Grampian in Aberdeen. And so this really is a very at the clinical interface of research, collaborating with clinicians and university researchers. And we recently just received funding from Target ALS Foundation, which is a charity in the US, to be able to follow this up further, to be able to develop this as a possible diagnostic test. So our future steps really with respect to this project are, as we were saying before, to develop this as a potential diagnostic test and to think about therapeutics that could be useful intervening in the earlier stages of the disease. But the other thing that we really want to do is to assess the general population for these sorts of signs, to see whether people who don't go on to develop motor neuron disease develop these clumpy proteins, whether there are people who have resilience to these sorts of proteins or not. And so assessing the general population from our bowel screening tissues that have been collected historically will be a really important thing to see to inform our future studies.